This is the master slave flip-flop which has been implemented by only with the NAND gate. Then you can see that we have used 7400. Therefore 1, 2, 3, 4, 5, 6, 7. 7 gates are there. Therefore we require 2 IC, and therefore we'll be connecting to 2 IC of 7400. And you can see we are using 3 input also NAND gate, that is 7410, and we require 2 gate, and therefore in 1 IC 3 gates are available, therefore 1 IC. Therefore we have connected here, you can look at that, this is the 7400, this is also 7400, 2 input NAND gate, and this is 7410, 3 input NAND gate. Only what we have done it here, therefore VCC and grounding already been connected, and these are all 14 pins. Therefore I told that right hand side numbering will change because it is a 14 pin. The last 2 are not connected. Now we'll start the connection. Before starting the connections, I want to tell you a slightly my way of simplifications that connections. What I have done, I have chosen this is in 1, in this case, in this pin diagram, you can see that in this case this is as 1, and this is as 1 and 2. Here this is I have chosen 2, this is I have chosen 2, and this is 3, this is 3, and this is 4. That means what I have done, it is if we overlap it, and therefore 1, 2, 3, 4, and the 5 will go to the second IC. 5 will go to the second IC, and exactly what is 1 and 2, and that will make it a 5 and 6, and 7 is the 3. That means in this case, and if you want to further conveniently you can connect it, you can connect in the other way also, but this is the method I have adopted to simplify the connections. Now we'll start with the 1. You can look at the gate number 1. In the gate number 1, the inputs are, you can look at that, 9 and 10. Output is 8, and in this case you can see the output is, in the gate number 1 output is Q. Therefore gate number 1 output is Q. Therefore I am starting from the end, and then we'll go to the beginning. Therefore we are starting from the end, therefore I am 8. Here is the 8, and that will be the Q. Therefore again I repeat, I am connecting here from the end to the beginning. Therefore this is the 8, this is the gate number 1, this is the 8 I am connecting as Q. This is the gate number 1. Look at the gate number 1, 8 is the output. Therefore I am connecting this is the 8 as the Q. And then you can look at that gate number 2's output is 6. 2's output is 6, and therefore I am connecting 6 as Q bar. Therefore I am connecting 6 here, and that is I am giving to Q bar. Therefore these the first 2 outputs I have connected. Then coming to the input side. The input side, you can see that one of the input to the 1 is coming from Q bar, and therefore I am coming to the Q bar here, and one of the input. What are the input? The 9, you can see it is the 9 and 10. You can see the 9 and 10. Therefore I am connecting to 9, connecting to the Q bar has been connected to 9. And then you can see that here also 2 also, you can look at the 2 also. One of the input is coming from Q. Therefore I am connecting to Q here, and coming to the input to the 2. What are the input to the 2? 4 and 5. Therefore I am connecting to 4 here. And you can see 1 still 10 is pending, and 2, gate number 2 is 5 is pending. And you can look at that you can look at the diagram that from output of the gate number 3 is the input to the gate number 1. What is the gate number 3? You can look at the gate number 3 is the output is the 11. Therefore I am connecting to the 11. You can look at the 11 here. You can look at that 11. I am connecting to the 11, and it will be connecting to the it will be coming to the input to the gate number 1. Therefore 9 and 10, because 9 is already connected, therefore 11 output of 3 will be coming to gate number 2 as gate number 1 as input. Therefore I am connecting to 11 is connecting to 10. 11 is been connected to 10. Then you can see the gate number 1, both the inputs are completed. Then gate number 2, the one input is pending. Then you can look at that gate number 2 is coming from 4. The gate number 4 output is input. Which is the gate number 4? 1 and 2 and 3 is the gate. 3 is the output. Therefore, you can see that I am connecting to 3 is the output and connecting to the I am connecting to the gate number 2 as an input. What is the input to the gate number 2? 4 and 5. The 4 is already been connected. Now I am connecting to 5. That I have connected the gate number 3's output is over and gate number 4 is output is also over. Now coming to the input to the gate number 3 and 4. Now you can see that one of the input of the gate number 3 and one of the input of the gate number 4 are connected together and given from the NOT gate, which is the gate number 7. Therefore, 5, 6, 7 are in the second IC. And what is corresponds to 5? 5 corresponds to 1, and 6 corresponds to 2, and 7 corresponds to 3. Therefore, let me create first 7. Now, because it corresponds to 3, therefore, in the second gate, 12 and 13. I'll just connect together. You can see in the second IC, I'm coming from the end, second IC 12 and you can see 12 and 13. Therefore, this is the 12 and 13. You can see the 12 and 13 I'm connecting together and it is given input from the clock. Therefore, this is one of the is given input from the clock. And then I'm coming back. Then I'm coming back to 3 and 4. Then 3 and 4, what are the 3 and 4? What are the inputs? You can look at the 3 and 4. One is 12 and 13 and 1 and 2. Therefore, I am connecting 12 and 2 together. 12 and 2 together. Here you can see I am connecting I am coming to IC number 1. 12 and 2 I am connecting together. And then output of 7, that means it is 11 in the second IC. Therefore, from 11 in the second IC, it will go to this, it will be connected here. Therefore, whatever I connected, therefore I have to output is going there. Therefore, I have connected that 3 and 4 two inputs. What are the 3 and 4 inputs I connected? 12 and 2. Therefore, output is I can connect any one of them, either 2 or 12. You can see it here. I have connected. Then our two inputs are also of the 3 and 4. 2 inputs are over. I connected from the NOT gate. Output is connected. Now coming to the another input is coming from 5 and 6. And 5 already I told 5 corresponds to 1 and 6 correspond to 2 in the second IC. Now what are the output of 5 and 6? You look at that 5 that means one output is 8, therefore and 8 of the second IC. Then it is coming to the input to the 3. What is the input to the 3? 12 and 13. You can look 12 and 13. Therefore already 12 is connected, therefore I am connecting to 13. Now another input you can come to the 6, this is corresponds to 2. Therefore, you can see there are pins are and the output is 6. Therefore, in the second output is 6. It is to be connected to the input to the 4. What is the 4? 4 is 1 and 2. Therefore, 2 is already connected. Therefore, I am connecting to 1. Therefore, you can see the 4 and 5 inputs are also completed. Output of 5 and 6 are over. Now coming to the input side. Now you can see one of the input to the 5 is coming from the output of 6. What is the output of 6? Output of 6 is 6. Therefore, I am connecting to this. I am connecting to the 6. I am connecting to the 6 here, and then it will go to where it will go. It will go to 9. You can look at that 9 or 10. 5 is inputs are 5 is 9 or 10. Therefore, I am connecting from 6. I am connecting to 9. And therefore, now another you can see the output of 5. What is the output of 5? Output of 5 is 8. Therefore, I am connecting to 8 and then it will go to the input to the 6. You can look at that, it will go to the input to this. What is the input to the 6? 4 and 5. Therefore, what is I am connecting? Connecting 4. I am connecting 4. Then you can see here the another input is coming from the 7410. Therefore, what is the 7410's in output? One I told you. Therefore, 8. Therefore, it will come to the 8, and then it will go to the 5. 5. What is the input to the 5? Input to the 5 is input to the 5 is, you can see 9 or 10, because already I connected 9. Then I am connecting to 10 now. Now you can see that another input is 6. Another output of the is 6 of the 7410. Therefore, where it will go? It will go to the input to the 6. What is the input to the 6 is pending? And that is the 5 is pending. Therefore, I am connecting to the 5 of this. And then I am coming, this is the 5 and 6 also completed. All input and output is also completed. Only remaining is 7410. Input is one input is coming from Q bar. Therefore, 9. You can see the 9. I can put it 9 here, and it is coming from Q bar. Therefore, I am coming to the Q bar, and you can see that another input to the 7490. You can look at that. That is 10. That is 9. I put it 10. This is the 10. That is, you can make it to, you can look at that, you can make it to J. Therefore, I make it to J here. Therefore, I am making it to J here in the input side. Now you can see in the similar way, in the similar way, you can come to the 2 dash. 2 dash. You can look at that. One of the input is coming from Q. One of the input is coming from Q, and therefore you can look at that. One is the input is coming from Q. Therefore, I am connecting to Q. And that what are the input? You can look at that 3, 4, 5. Therefore, I am connecting to 3. Connecting to 3. You can look at that. I am connecting to 3. And you can make 4S. You can make it 4SK. Therefore, to the input side, I am connecting to 4 and make it to input side more K. And then you can see here there are 1 dash and 2 dash. Two inputs are connected together and given to the clock. Therefore, what is remaining? 3, 4, 5. You can look that 5 is still pending here, and in this case 9, 10, 11. You can see that 9, 10, 11 is connected together and given to the clocks, and you can see that 11 is connected. 5 and 11 is connected and given to the clock. I am connecting to the clock. And then we'll see the output. Verify the truth table of JK flip-flop. Now you can see that at the initially key, this is Q, initially Q equal to 0 and Q bar equal to 1. Now as we give the clock pulses here, there is no change. There will not be any change. You can see that there is no change is taking place. Now I will make it to J equal to 1. I make it to J equal to 1, and then I give a clock pulse here. That I give a clock pulse here. Then you can see that it has been changed to 1. It has been changed to 1. And remaining, if I give further clock pulses, it will not react. You can look at that, it is not reacting. Then I give it to both, then I make it to both 0, 0. Then I make it to K equal to 1. You can see K equal to 1. I give a clock pulse here now. You can see that now Q equal to become 0 and Q bar equal to 1. Then I make it to both equal to 1, 1. Then I make both equal to 1, 1. Then you can see that every clock pulse, the change in state will change. Therefore, you can see it, every clock pulses, it is changing. You can see every clock pulse it is changing. That is the truth table. We realize the truth table. That is a toggle, and that is the when both J equal to 1, K equal to 1, it is a case of a toggle, and this is the truth table we realized.